Do you want me to video?
Yeah.
Okay.
Right, so
Let's just introduce Ben first of all. Well, Ben is a former student of life, environment and people. He came to us course, I think it was in 2004.
I think so.
Yeah, which was kind of quite an interesting year. The year that it nearly got banned.
Nothing to do with me though.
It had everything to do with it. You were wholly responsible.
Just as well as whole.
So yes, and say a little bit, just to say a little bit about what's gone on for you since then.
Yeah, I mean, I suppose when I first met Alan, I walked into a lecture. I was one of these guys you see walking around university with a massive lovely hat on in the middle of August, hiding and sort of trying to figure out how the world worked. And I sat through these lectures with Alan, and slowly, sort of a few ideas that I felt, he started corroborating and then building upon, and it sort of blew away my worldview and replaced it with something that was a lot more pleasant. I then sort of left university, went off to go and work in the real world, and Alan and I had a bit of contact in the interim. I got to a point with Inclusionality where I almost hit a brick wall, I think, in my thinking, and things happened in my personal life, and I drifted off and went and worked in the corporate world for a while. About 6 months ago, much like one of Alan's paintings, I suppose, I sat down and started writing this paper, and 20 pages later I thought, there's something in this. And the first person I thought of was Alan, because it was, most of it was derived completely from Inclusionality. So the next thing I did was send Alan an email saying, "Dear Alan, I'm really, really sorry, I hope you remember me. I'd be really grateful if we could get back in touch and start sharing some ideas." And that's basically what we've been doing for the last 6 months. I suppose one of the really interesting points during the 6-month period was about a month in, when I was developing my ideas. I was still thinking in terms of a single fabric. I was still thinking in Einstein in terms of relativity. I didn't realise I was, but I was. And Alan pointed it out to me. And it's a bit of the example of conflict. I could have chosen to say, "Oh no, I know what I'm talking about," and we could have had a bit of conflict. But I thought, no, that's not the way to go. The way to go is Alan knows what he's talking about. See what he's got to say, and I'll listen. And it was the idea of space, the all-pervading space, the inner and the outer, that finally I understood. And I then went and looked back at my belief of how the world was made, which was all built from fractal curves, and it was actually quite a reductionistic view that I had, even though I thought I was an inclusionist. I wasn't. And within 3 days, this sort of shape had appeared out of fractal maths and transfigural maths. And I'll show it to you later, and I'm sure you all recognise the shape of this. Al mentioned it earlier, the 0-point fractal, and that's something I think is really interesting. But sort of start the talk in earnest. I was going to start on the BBC programme that was on recently, actually, as Alan skirted round. I can't remember the name. Watched Over by Machines of Loving Grace, something like that. And the idea of nature, reality, the universe, life as a machine, as a mathematical and a mechanical machine, which is the rationalistic view, which is promoted by effectively all throughout sciences, politics, our social lives, economic systems. Everything is based around this quite a cold view of us as machines. It's how we see ourselves, it's how we see other people, it's how we relate to other people. I think that feels wrong, and I place value in feelings. I place value in things that are unabsolute, which I don't like to think that they're a gambit of of a selfish gene in sort of inexorable drive towards self-replication. I don't agree with that. I think it's far too elaborate for that to be the explanation of what consciousness is, what life is. So there are a few things you start examining at that point. Concept of infinity. What is infinity? You think of the Big Bang Theory. You think, where did this view of machines come from? And it came from the Big Bang Theory, because you had nothing, then you had a Big Bang, and then you've got this universal cool down, and everything in the universe, life, the universe, everything, is part of this universal cool down. Starts with the Big Bang Theory, it evolves and changes through fractal geometry, and then it stops when the cool down is complete. And that's the rationalistic view of the universe. We are expressions of that. It includes for infinity. The fractal geometry is infinite in its nature. And so they can say, oh yeah, infinity is a concept we can build into our rationalistic view with a start and an end, because it's created by the geometry that's created by the energy of the Big Bang. That's fine. I would sort of take a step away and a step back from that and say, what if there was no first Big Bang? What if there's always been something there? And the Big Bang might have happened, but it might have been part of a cycle rather than the first thing ever. And if it was part of a cycle, that implies that there's far more levels and complexity to infinity than we possibly imagine. So that's an interesting point to start from. So dual infinity on the board there. This is a quote from Leibniz in possibly 1695. The translation's a bit smudged, so you can't see the date. But it's a conversation or an interaction he had with Blaise Pascal, who anyone who knows physics will know about, and both of them acknowledge that the infinity in material things is such that there is always something smaller, there is always something larger, no matter what scale you observe. So we start at the room here, focusing on a person. You can then focus in on an organ and a tissue in the organ and a cell in there, an organelle and a cell. So you fire into the nucleus, there's DNA in there, which is full of chromosomes, and the DNA is made of molecules, that's made of atoms. The atom's made of protons, neutrons and electrons, which are made of quantum particles, and we still don't know what the smallest thing is. We keep trying to say that's the elementary particle, that's our starting point, fantastic, we can stop looking, but really annoyingly, every time we think we found it, it falls into 1,000 million pieces. And you sort of think, it's back to the drawing board. And it's the same as you go up, you've got the planet, the solar system, the galaxy, the universe, whatever's outside that, you know. So that's the idea of dual infinity, is to stop imagining the smallest point, stop imagining an elementary particle that everything's made of, and stop imagining an edge of the universe, an edge of reality, and just accept that you could keep reaching down and getting smaller forever and go up, and you could keep reaching up forever. You can that's infinity. That is infinity. So that isn't infinity in terms of infinite complexity within the space-time fabric. That's infinity, pure and simple, stretching out forever. And that's the definition of it. Now we actually use infinity in maths quite regularly. There's a figure called pi, which you can see up on the board there, which has got an infinite number of decimal points, and we build it into virtually all of our geometry as a standard figure. We've hidden it, but it's actually building infinity in its realist sense into rationalistic maths. And the other interesting sign up there is the figure for infinity, which is used by rationalistic maths, which shows an edge and a boundary, so it's almost like a folded space-time fabric. It's not actually infinity. That should have open ends. It should be more an X, or maybe even a crucifix. I don't know. So that's dual infinity. How can we draw a picture of dual infinity? How can we draw a picture of something that's always got a small scale and something that's a large scale? Well, what's used in physics at the moment is fractal curves, part of chaos theory. Chaos theory shows us that even in perceptually chaotic systems, there's an equation usually you can use to pretty much map out that pattern, that seemingly random pattern, or at least approximate the random pattern, which is what I think is the important acknowledgement, is that any equation is an approximation of reality. So a fractal math is an approximation. It's a very good approximation, but it's an approximation. Fractal geometry. This is Mandelbrot explaining that. You've got Mandelbrot over there on the left-hand side, and then I've zoomed in on a tiny weeny part of it just to show you that it just carries on. The same shapes replicate again and again and again. And that kind of gives you an idea of infinity. You can keep zooming in, and there's still more detail, there's still more to zoom in on. You can zoom out, and there's still more, a wider expanse to view. So this is chaos theory. Bit of some examples of fractal geometry in nature and different types of fractal geometry you might not see. Top left-hand square there are trees in winter. And then I like to look at the human blood capillary system and sort of see certain similarities within that. And obviously they fulfill the same functions, so it makes sense that they look in a similar sort of way. It's a distribution system. And then you can look at, say, the fractal curve at the top there. I won't name that one, but this is a way that the shape of trees can be roughly approximated by fractal mathematics. It's too perfect. Nature is not as perfect as fractal maths. Nature includes more. It includes something else, which is actually space. Obviously, it's the nature of space which makes nature more natural than fractal maths. It's smoke here at the top. That's it's smoke with two different light sources behind it, intermingling, reacting. And then if you look down at the strange attractor fractal curves down at the bottom here, you can see how the strange attractive fractal curve is quite analogous to smoke, so the behaviour of smoke can be approximated with fractal maths as well. This is traffic in Shanghai. There's a bit of fractalness to the way humans driving. Bottom left-hand one there is something quite close to Alan's heart. That's from one lifted from one of his papers. That's under my ceiling. And you've got lightning over there, and I've put a fractal next to that, which sort of shows you how you could maybe start to map lightning using fractal geometry. And this one's interesting. Can anyone have a guess what that is? Fireworks. No. When I look at it, I think it looks like space. I think it looks like something off a Hubble Space Telescope image. It's actually a brain scan for neuronal behaviour, which I think is absolutely amazing when you consider that against. If a tree looks like a human capillary system because it does the same thing, why does a human brain scan look like other things? Is there something in that? Let's go a bit further.
Which is which in that brain? Where's the neuron and the yeah?
This you can see the axes there.
Is that the axon?
The axon there,
right?
And then the heads.
What are the yellow things?
I guess that's just the way they've tried to show different levels of activity on the scan. It is an actual scan though, you can see the edge of the bit there. So it's all that's something that really astounds me actually, is the similarity to the way the human brain is and other things. And then also a little bit about consciousness, how I think it arises possibly later, which fights against this idea of us being a machine. So these are 3D fractals, or attempts at 3D fractals, because obviously all the fractals we've got at the moment, or the ones I showed you on the previous page, are actually two-dimensional. You can zoom in and out, and that makes them appear to have 3 dimensions, but they're two-dimensional, they're infinitely complex two-dimensional graphs. So people have tried to make 3-dimensional fractals and to exhibit infinite surface area across an infinite number of planes with infinite detail, etc. Bottom left, that's a Mandelbrot. It's an attempt by someone to turn the Mandelbrot into a 3D structure. It's an utter failure in my opinion.
Too cozy.
It looks like a sea urchin, yeah. But a sea urchin wearing a tea cozy, I think we're going for. Big problems with the Mandelbrot are that it requires a discrete boundary. You have to have the outside to be able to see it. you didn't have the outside. If you cut this, if you tried to look inside that mandelbulb, what you've actually got is a conflation, which is what Alan was talking about earlier on, because it doesn't include the space. The only place on the mandelbulb that includes the space is at the vanishing point at the top. That is beginning to exhibit something like true 3D fractal behaviour. This is a Menger cube. Now, this guy Menger is one of the people who kind of realised what was going on, what you needed to do to make a 3D fractal. He built in space. So what he did was he thought, infinite surface area, the only way we can do that is to take bits out so that we've got more space to be able to, to see and to get access to the surface area inside. You have to have space to have a 3D fractal. You have to. And so that is a massive, massive boon for inclusionality, in my view, is that as soon as you try and make a 3D model of what the rationalistic geometry says the world's made of, you have to put space in. There's only one type of maths I know of that's attempting to give space a presence, a zero presence. It's called transfigural maths, and it's obviously born from Alan's work and Lear Shankuli, or Lear Shankuli. These top right hand corner, that's a couple of images that I pulled off a a transfigural geometry paper. I don't actually understand transfigural geometry 100%, I have to admit. I need a crash course.
I think it's broad, but it's well on the way.
It's getting there. And what I find really interesting about it is the top one. I'll describe what these pictures are first, actually. Top left is the trajectory of an asteroid as it's affected by the gravity of another body. Picture there is obviously the orbit of planets around the star. It's quite obvious. Those two, I think, quite closely resemble transfigural maths. They also quite closely resemble strange attractive fractal curves, which I showed you earlier on, which are the ones that look like smoke. So we start to see that transfigural maths might be able to be used to come up with some analogies for gravity and how gravity works. And then you start to think, well, okay, maybe the strange attractor might have something to do with that as well. And so you move away from this idea of a linear force linking two things together into this sphere of influence of these strange attractive fractal curves which interact with each other and become an equilibrium of a dynamic flow rather than a direct link. It's the difference physically in terms of cosmology between inclusional thinking and rational thinking is that. And then you sort of go, okay, so what can I see in cosmology that might start to sort of look like a strange attractive fractal curve? It might look a bit like transfigural maths. And this is entropy at the birth of a galaxy. And that's really interesting that entropy looks a bit like the maths that you could use to model gravity and forces and inductive influence, or inductive influence, which is the term we'll use. So entropy, inductive influence, which by that I mean light, gravity, etc. You start to think maybe inclusionality's got something to teach us about those aspects. This, as an aside, just to go back onto consciousness, is an image of brain activity in a human embryo during development, which again, if you see the curves, the shapes, it's the same sort of shapes. And you start to think, well, what's in that? Is there anything in that? I mean, a friend of mine used to play a game where he used to do that, and send me a photograph, and he put on the text message, is this an arse or an elbow? And you've always got to be careful when you're doing this kind of thing that you're not doing that. But if you don't look at these possibilities, you're not going to learn. You might be wrong. Just like Alan says, I don't care if I'm wrong. If
That's a hang-up I have.
To be honest, I do really. But yeah, if you could, in fact, all it is if you can learn something from this stuff, you've got a duty. If you can see it, you've got a duty to actually do it, to be right or wrong. This is a 0-point fractal. This is what happens when you add chaos theory, fractal geometry to inclusionality, the concept of the zeroid. And what you see is actually just what you see every day, all the time. That's a galaxy on the left-hand side. That's the solar system. That's a gold atom. That's a human brain scan again, or a model of a human brain scan. Up at the top there, that's a DNA molecule. I turned it on its side so it looks less like a ladder and more like a flow. Because it's always presented top to bottom like a ladder, like a structure. As soon as you turn it on its side, it starts to look like it's flowing, and that's interesting as well.
That's when you see the resemblance with the super channel, which are represented horizontally instead of vertically.
Absolutely.
Very interesting, yes.
Yeah.
You're right, it's always represented vertically, isn't it?
Always.
And that immediately affects the way we think.
It's the King famous bit, it's a ladder. It's a ladder. It's all very, very fun.
Exactly.
So this is what you've done is fascinating.
Exactly. And you know why I did that? Because it fit on the slide.
But yeah, it's all about perception.
That's not the lucky coincidence, that is. But coincidences don't really exist today. So that's a 0-point fractal, and it is all that is the logical progression of chaos theory, inclusionality, dual infinity. What you have is a zeroid here. Rational science will tell you that that zeroid is a solid object in space. We know that when you zoom in on that, say, okay, this is even better, that one, which is the Earth. Oh, there's the Earth. We got the Earth there. We know that if you zoom in on the Earth, it's not a solid shape. We know it's made of molecules, we know it's made of atoms, and we know that they have space in them as well. And so that's the all-pervading space. That's the shape that Alan's describing to you. That's how space pervades through tangible matter, because tangible matter is perceptual. It's something you see it, but actually as soon as you get close to it, it splits into 1,000 million pieces and becomes totally something you didn't expect. And that's kind of that's the idea of a 0-point fractal, really, and it's really simple, and you see it every day, and you see it in the sky at night. And that's it. But if you check around on the web, I can't find anything about that anywhere. It's insane. There we go. A couple of other things. Observation point is a term I use every now and then. When I say observation point, that's the point in which this pen is a pen. So at my observation point, this pen is a pen. There's another observation point, there's an infinite number of observation points at which point this pen is a molecule, or it's a collection of molecules, a collection of atoms, and every time that's a different observation point. When you're stood at an observation point, you can be a bit more rational and you can make an approximation about what you're seeing, and that's what rational science is. Rational science is an approximation of what they can see at the observation point that they are at. That's all rational science is an approximation of what you can see. It's not the reality of what's there, which is the main message, I think, of inclusionality, really. Everything can be broken down into zeroids, which is dots in space, unless you perceive it otherwise. So yeah, as I say, zeroid fractal shows a possible description of the shape that may not be there. We talked about sphere of influence earlier on. This is the sort of the way that the zeroid reaches out through the intangible to influence other zeroids in a way. So you might call it a gravitational field or a light field. How the forces transmit through the intangible, how does this all work, is a question that I think has been asked earlier on. Forces are also 0-point fractals. Light is photons, gravity is gravitons. So within the intangible space you have other 0-point fractals which aren't tangible to matter. They can interact with matter at where the zeroids all come together, but it's not. It's a very, very more complex, infinite picture, and space is actually full, in my opinion, of infinite numbers of different sort of.
Space is full of cavities.
Space is full of cavities. That's what it's. I won't go into it now because that's another sort of jump round. I call it jump round the fractal corner, when you kind of you go, okay, so I'm at a point where mass is mass and light is an intangible force. If I stand on a photon, light becomes a tangible force. What's holding the photon together? That's around the fractal corner in space. That's infinite. That's pretty mind blowing. I think it is. So entropy is another thing that I've been obsessed with since school. It's the only thing in chemistry and physics at school that interested me. I used to fall asleep in all the lessons and I'd bottom straight out until I started getting back involved with Alan and realised that physics and chemistry were far more interesting than what you taught at school. Entropy was the only thing I liked. The reason I liked it was because the guy, Rudolf Cassius, who sort of defined it, couldn't handle the increased entropy in the universe, and he decided he was going to, opt out. I won't tell you how he did that, but poor guy. And that was in 1865. He was worried that the world was reducing into chaos because of the theory of entropy, so he opted out. We're in 2011 now. It's not much more entropic, really, is it? So there's something about entropy that we don't know.
Sorry, for us non-scientists, can you describe entropy, please?
Yes. Entropy is part of the equation in classical thermodynamics of reaching dynamic equilibrium, of reaching stability in a...
It's usually represented as the degree of disorder.
Degree of disorder.
Okay, so absolute entropy is absolute incoherence.
Yeah.
Yeah. Anything can be anywhere, any place, any time. Yeah. So and it's a condition of absolute independence. Yeah. Which is what statistics is based on. The idea of randomness, fundamentally. but that idea itself comes from the logic that splits matter from space.
Yeah. So I look at entropy as something, because entropy increases any change, any thermodynamic change, any physical change. Me doing this with my hand releases entropy, and that entropy never dissipates. It never goes away, according to the law of thermodynamics. It's almost if you imagine yourself in a pool of water thrashing around, but the waves never go. That's kind of what the picture of entropy we're given is that. It's essential to reaching dynamic equilibrium. The other part of it is it's quantitative, it's not qualitative. So we're not firing out particles of entropy. Entropy is effectively something of this magnitude is happening somewhere in order to allow stability in the tangible. What that actually is saying then is something of this magnitude is happening in the intangible, which is allowing stability in the tangible, and it's the interface between the tangible and the intangible. So entropy is far more important. There are lots of ideas banging around about what entropy is and how life relates to entropy. James Lovelock claims that life is the sink for entropy, so we suck entropy in, according to James Lovelock. I'm not convinced by that myself, because I've got a few other ideas. So you could say entropy is the increase in disorder in the intangible, or you could say it was an increase in chaos in the intangible. We've had a look at chaos theory earlier on, and usually you can find order within chaos, order within disorder. So could entropy have some ordering effect on the universe? Could it actually be almost the opposite thing from what we think? Could it be an organisational thing? The way the intangible shapes the way the intangible shapes the tangible, or vice versa.
So in the mathematics, can entropy be reversed?
No.
So in the maths, it doesn't allow that.
Yeah, if you have an equation where you say you evaporate water, entropy is released.
Right.
If you freeze the same water, condense the same steam back into gas, entropy is still released. It's not sucked back in.
Right.
Entropy is not a physical thing to be sucked in and out. Entropy is effectively
Measure of
disruption.
Disruption.
Yeah, it's life, it's activity, it's inductive influence.
This actually relates very, very strongly to the question earlier about how evolutionary diversity arises.
It's interesting.
And how what classically is thought of as a degenerative process can be thought of as a generative process.
So tomorrow we talk about social
Yeah.
as well. when I slightly tongue-in-cheek, I call myself an entropy fighter in the social field.
Or an entropy organiser, I'm sure. So yeah, that's my thought on entropy. You've got a couple of pictures there on the board. I'll come back to those in a second. I just want to put you on the bow of the boat actually. A sailing yacht travelling across a very flat sea. You're sat on the back of the boat and you're watching the wake of the boat very calmly rippling through the water behind you in a very uniform fashion. At molecular level, when the boat's moving through the water, that's extremely chaotic. It's extremely entropic, you might say, within the water. Those waves aren't there at molecular level. It's molecules bashing off each other and a bit of chaos here and there. And slowly, as you sort of zoom out, that chaos begins to organise itself into this solid wake, and then you'll have a dolphin maybe swimming along on the back of the wake, because that wake is inducing the dolphin along, it's pushing it along, it's a force. So the entropy that's created at molecular level by a boat travelling through the water becomes a force, a wave of force, of inductive influence. Could that be what's happening in the intangible? Could entropy actually be adding to, combining, taking away from itself and becoming inductive influence and force? You relate that back to the idea of the sphere of influence. You imagine that there's this field of entropy which is coming off a body of mass up through the scales of infinity. The molecules whizzing around like that inside it. Even the gold ring on your finger is actually extremely active at molecular quantum atomic level. It's emitting entropy. It becomes a force, it becomes mass. The Earth, imagine the sheer amount of mass in the Earth and the amount of entropy that's just being generated, just coming up, bubbling up through the scales of infinity, just keeping the structure. And you get this sort of cloud of, if you imagine the strange attractive fractal curve and the way smoke attracts itself together and becomes intertwined. If you take the moon and you take the Earth and you put them close to each other and their spheres of influence become in contact and begin to influence each other and come to dynamic equilibrium, you have an orbit. And it's not something like that in space-time, and it's not a line like that between them. It's a dynamic equilibrium of flow, of entropy, up through the scales of infinity and out. That's what I'm thinking.
Comment. I don't know, it just reminds me of the idea of someone, when someone dies, you know, the soul or whatever, there's an energy that is perhaps let go from a body, and you're aware there's something going on, but you don't quite know what that energy is joining, and so there's sort of, this reminds me of that, and kind of...
yeah, this is something off to one side Alan and I might possibly have been talking about. But we're kind of keeping that off to one side at the moment because of the scientific importance to what Alan's done to inclusionality. There's massive scientific importance, and if you attach things to it, that rationalistic scientist can say you're a hippie and dismiss you and actively fight you. It's not what we want to do. We need to. There's real value and truth that people are ignoring. We can't give them an excuse to do that, is my opinion. Oh yeah, the pictures. This is actually by Claude here at the front and on the bottom. I like to imagine this one moving, spinning round like this. And you see the smaller units in here. If you imagine that's chaotic entropy fizzing away at the point where the energetic change is happening. As you move out, the shapes get larger, more organised, more uniform, rotate slower, and that's the picture of entropy as energetic exchange in the intangible that I have. And the top there's an Arab mosaic. That looks quite like entropy to me. It looks like it's organising itself. That's from an ancient Arabic sort of tile. Mosaic is the word, isn't it? So we're going back to the idea that indigenous people already knew what was going on. I think that's quite obvious when you look at Celtic art, Arabic art that we produce now. This is a page from the Book of Kells, which is there for illustration, really. It was done by Celtic monks in the 6th to 9th century. What it is a mixture of Christian artwork and Celtic artwork, and the Celtic worldview and the Christian worldview. What you see is there are actually lots of life forms, if you like, built into the Celtic artwork, particularly up at the top right-hand corner. If you can see the lion, which is part of the Celtic fabric, and they've drawn zeroids. They've drawn all the things that we're talking about here. It's very complex. And then you've got the Christian guy sat at the top looking really miserable because he's sat outside it looking in. And the other guy there who's having a word with the lion. You see the guy's face; they're not having a nice conversation. These Celtic monks are making quite a comment there on what they're being forced to do. But the Celts knew. They kept these pictures that the Celts had drawn. It really does describe inclusionality really well, and I love this page because it's great to see. Great to see them sitting there, building in inclusionality into one of the earliest books of Christianity there is. I think that's great. So yeah, that's kind of where we come to. So when you build in fractal geometry with inclusionality and dual infinity, what you end up with is the zero fractal, which is something we can see every day. What you end up with is a new model for inductive influence and entropy, which is worth having a look at. And it actually gives you a mechanism behind these esoteric ideas that rationalistic scientists will pump at you as being truth. They couldn't actually model what they're telling you. They can give you the maths for it. They can give you the approximation for it. Whereas what inclusionality does is it shows you visually, in a way, I think. There we go. So this is the last slide. Implications, cosmology, gravity, we've thrashed to death. Nuclear interactions. I personally believe that electromagnetic scale, gravity are actually all one force. It is just entropy organising itself up to infinity. Gravity is a weak force at its scale. If you think it through rationally, it makes perfect sense that gravity is perceived as a weak force compared to, say, electromagnetism or the others. According to this model, it doesn't make sense. What I like to look at is whether you can apply it to different bits of science, different things in the world. Does it make a difference? Watching a programme on the BBC about the evolution of social behaviour in lions. Lions are the only big cat that exhibits social behaviour. The reason that they came to, in the end, for the evolution of social behaviour in lions was to do with the control of the intersection of two rivers. At the intersection of two rivers, you have a massive amount of flow, massive amount of inductive influence. You've got organisms all over the place. As Alan was showing you earlier on with his slides, there's water, lots of water seeping out through the banks, so you've got a lot of greenery around there. There's a lot to eat. Animals are coming to drink there. It's perfect for lion pride control because that's just like McDonald's. It's absolutely perfect for them. And that's why lions evolved social behaviour, to control river intersections, apparently. Fair enough. So
there's a zero fractal coming into life.
Zero fractal coming into life. Rivers are zeroid. And this is what we're saying about the increase in evolution around the zeroid. The other animals are attracted to the zeroid because of what the inductive influence of it is, which is I can give you food, I can give you water, and it sucks you in. The other animals are around, and that sucked the lions in. And the lions have developed this really uneasy social system where they're almost killing each other all the time to control these rivers. What's really great is you've got the lion pride that controls the river intersection. Then you've also got the zeroid pattern of lion prides that form around the main pride who are trying to get in and take control. And so you can actually look at the evolution of social behaviour in lions purely in terms of the 0-point fractal and inclusionality, and that's what it gives you. Cities, it's almost the same as lions, it's quite obvious. Loads of humans together, loads of creativity, loads of change, loads of money. Sucks you in, the city gets bigger, the inductive influence gets bigger, the zeroid mass grows, bang, cities, town, village, city. The last one is consciousness, which is where we started and where we'll finish. I like the idea of consciousness as a construct. whereby you've got loads of little bits in your brain which all do specific jobs and they fire neurons to sort of practice before. I believe personally that consciousness isn't in the brain, it's the entropy field created by the firing neurons. And it's actually an average, it's an approximation, and so it's not a machine. Because of infinity, if you had a machine that was trying to decide to get out of bed in the morning, can you imagine what goes through your mind in the morning? Alright, okay, have I done this, have I done that, do I want to do that, do I feel very well, how's my dog? And eventually you sort of go, just get out of bed now. Go and shower, Jesus, forget this stuff. A machine couldn't do that. A machine would have to calculate everything to base principles. That's why we're not machines, because we feel, because we approximate, because we take a leap of faith. That's what consciousness is it allows us to live. And that's effectively it. There are things that fire off the back of that idea of consciousness, i.e. consciousness is out here rather than in here. So what does that mean in terms of what you were talking about? I don't know. Is there a network? How does all this work? But it all becomes rational science to look at then. Instead of just to ignore people who make these claims, you can actually see, okay, there is actually a scientific model that fits these ideas. Oh dear. No, and you've got to go, you owe it to the world to look at it. No matter what people say, it's and that's it, that's the end.
Lovely, thanks ever so much. And that's where Alan couldn't keep up. Alan's quite slow at least on the uptake sometimes. But uptake is what it's all about, isn't it? So that's really good. Angela, you want to introduce yourself?
Hi, I'm Angela Arnold. Do you want to say it?
No, you don't.
I'm a teacher and I've been interested in this because I studied here at university, so I kind of kept interested in the whole idea. And especially in terms of education, because obviously being a teacher, that's my sort of area, so that's what I'm interested in. And this is Lucinda.
So Phil's just disappeared for a moment. Just to give you a little bit of a feel, it's amazing how the thing called time is general conversation. We might want to include lunch. I'm suggesting to get lunch. Well, you can actually get sandwiches down in that little room there if you want to, or you can go over to the Claverton rooms. But whichever, or there are other eating places as well. Whatever we do, I suggest we get back here by 1:15. Yeah, we do our own thing basically in terms of lunch and conversation and talking to one another is concerned.
Is in supporting communities in environmental change issues. So I sort of carry what I call a scientist activist sort of mantle for a number of years, so 30 odd years now. But way back, I was deeply troubled by the ideas of motion, the ideas of absoluteness, certainly deeply troubled by things such as magnetism and gravity, and the nature of space. And so, partway through, or just about at the end of my PhD studies, I kind of saw the interesting link to inclusionality. So I'm sort of a newcomer to this. And bearing in mind that in terms of the development of my worldview, I guess, I've come from conventional science through questioning and an activism in all things, through to a post-normal view, and post-normal science is another kind of interesting and emerging questioning of where we're going in science, particularly the way it relates to social settings, but indeed the progress of science itself. And so I felt that inclusionality kind of brought a lot of things together. It's the next chapter for me, as I really embrace inclusionality to deal with the problem of physics, not the problems in physics, but what I call the problem of physics and cosmology. And so my kind of project at the moment is to, which I won't probably talk about this evening, but at some stage we'd probably like to, is my my little project to do with talking to conventional physicists about the ideas of inclusionality. And some of those conversations so far have been pretty fascinating because physics, deep physics, is in crisis, and that's fascinating and that's healthy and that's good. It depends who you talk to. The experimental physicists, the game's sewn up, we know what we're doing. We're looking for smaller and smaller and smaller. Okay, if that ends up in space, then we'll have to then sit back and ask further questions. The theoretical physicists and cosmologists are deeply troubled by what is unknown, by where things are going, by the anomalies that we continue to find, and that's the area that I'm quite fascinated in, and where I think inclusionality is going to make some pretty big impacts. But that takes time. So I guess my project, what I'm into at the moment, is to build those bridges to invite questioning from conventional physics. That is kind of sitting there almost latent at the moment with people like Penrose and Hawking and others who are deeply troubled, who are asking the question, where to from here with quantum theory, where to from here with the other theoretical frames that we've tried to develop to understand the nature of this thing called reality, and that's pretty fascinating. And I think I'm getting a lot of joy out of precipitating and facilitating those kind of debates. Working out where people feel safe is the important part. Is people have got to feel safe before they are comfortable to take the next step in thinking. No matter how old they are, no matter what calling they come from or what perspective they take, I think it's really important that people feel safe as they begin, because this is big stuff. I remember my initial exploration, and I haven't done any deep exploration into alternative agricultural thinking, because that's one of my other areas that I've done a considerable amount of work in, organic agriculture and biodynamic agriculture, is that very thing, biodynamic agriculture and philosophy and all of that other sort of universe of understandings as relates to agriculture. So I guess what I'm saying is that this exciting and this tantalising and this wonderful itch of this great unknown is just so exciting, and I think there really probably is no answer, but rather some fascinating paths that we will continue to explore as hopefully developing an intelligent and feeling species in the universe. So that's kind of a really rough sort of a thumbnail of what I am as a human being. The area that I've kind of concentrated right on in terms of my social responsibility as an activist and scientist is this thing called community-based auditing, which seeks to bring community into meaningful and informed participation and involvement in decision making and strategic planning of their worlds in terms of natural resource management. So that's just a tiny little bit that I've been working on the last 10 years. So that's my thumb. I'm sorry, I've taken up too much time.
Not at all, but it's just, could I just emphasise that Phil's talking tonight, okay, now it's not in here, it's in the same building, but it's in a room 1.32 at 5:15. Okay, so it's just to make sure that everybody is aware of that, to get into Phil's notion of community-based auditing.
If you're not, there's a spare copies of our programme here, but yes, it's in this building, but it's two floors down.
Okay.
And you're going to access it on a different route from the way we access it.
Is everything being recorded?
Well, no.
How much is being recorded, Jack?
What's being recorded at the moment is, it was just for Alan's talk, and then I was just asked to continue in relation to the next, and I've just got Phil talking about what he's doing. But if anybody doesn't want it, their voice to be on, that's perfectly all right.
Okay. No, the idea was we can't come. I would really love to hear you speak, and I won't be able to be there. So
Yeah.
Whether it's
Yeah, no, my intention tonight is to film Phil,
great.
and then with Alan's talk, as well as Phil's, to put those on YouTube, because, yeah, and then we can let you know where they are, okay?
That's great.
Okay.
Okay, so we can mill around, we can find food, but we're now foraging in red fractals. And as I say, let's just meet back here at 1:15. I mean, we can stay here if you like, it's fine. But meet back here at 1:15 so that we can continue at the next stage. Okay.
That's sent round to them.
If you don't want to lose them, I think you don't take them.